U-substitution for integrals. Here we have another example over here. We're looking for a U-substitution, and it's usually a pretty good indicator when you see a set of parentheses that what's inside that set of parentheses might just be your U. So we're going to look at 16 minus x cubed, take its derivative, that'll give me a negative 3x squared, and I do see a 5x squared. So I'm off by a constant multiple. Instead of that negative 3, I want a 5. That's a constant multiple, and we can manipulate that and make that happen. So I'm going to go to the side and I'm going to say let u equal this quantity of 16 minus x cubed. And I'm going to take the derivative of u and get du. I'm going to take the derivative of the right-hand side of the equation with respect to x. I'm going to get negative 3x squared with respect to x. And again, I'm looking for a 5x squared. This is going to be my u. And in order to make a 5x squared happen, I need to get rid of that negative 3. So I'm looking at a negative 1/3 du is equal to x squared dx. And now I will put the 5 into the problem, get negative 5/3 du equals 5x squared dx. So I basically ripped the coefficient off the x squared dx, and then I put what coefficient I wanted back onto the x squared dx, which is my 5x squared dx ends up being a negative 5/3 du. So this will turn into the integration. I'll have a u squared on the denominator, and I need 5/3 du, negative 5/3 du, which I don't like the way I just wrote that, so I'm going to change this so that it's negative 5/3u squared du. And I'm going to also take a moment just to get that coefficient completely to the outside. So I have a negative 5/3 times the integral of 1/u squared du, which you can tell I'm taking some baby steps here. But now I'd like that 1/u squared to be rewritten so that I can use a power rule, which I will do. Negative 5/3 times the integral of u to the negative 2 this time du. And now this becomes a simple power rule integration. I copy my coefficient and I take my u, I add 1 to the exponent. Negative 2 plus 1 gives me a negative 1 divided by that new exponent, that negative 1, plus c. So I have a negative times a negative gives me positive. I'll have a 5 on top. The 3 is on my denominator. U to the negative 1. I'm going to bring the u to the denominator to make it a positive 1 plus c. So now I'm still looking at putting my x's back into my problem because the original problem was given with x's and I need to respond with x's, not with u's. So I have my 5/3. My u here was 16 minus x cubed, 16 minus x cubed, and then plus c. This should be the answer to my problem. And I can check that answer simply by taking this derivative. I'll go ahead and write chat, and I'll bring it up here. Give me the derivative with respect to x of 5/3 times 16 minus x cubed plus c. Now in order to take this derivative, I prefer not to do a quotient rule with the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom square. So I will take this quantity and raise it up. So I'm just going to rewrite my question for a moment. And this will be, matter of fact, I'll keep my 5/3 to the side. And I'll just say 16 minus x cubed to the negative 1 plus c. And now I'll take this derivative. These are logically equivalent to each other. So when I take the derivative of 5/3, 16 minus x cubed to the negative 1, this negative 1 comes out and multiplies. So I get negative 5/3, 16 minus x cubed, quantity to the negative 2, plus 0. Oh, wait, I have my chain rule, don't I? What is the derivative of 16 minus x cubed? That's a negative 3x squared, and now plus 0. So I'm going to make this neat here. My 3's are going to cancel. A negative divided by a negative makes a positive. I'm going to have a 5 on my numerator. I'm going to have an x squared on my numerator. And all of this stuff is going to go into the denominator. 16 minus x cubed. Quantity squared. I will exhaust that negative by doing that. and then plus 0, and that does look like it was the original integrand on the original problem way back here. So it does indeed check, and I'm good to go with this being my answer. And that wraps up question number 3. Okay, again, find your u as a quantity where your du is sitting in the original problem, but possibly off by a constant multiple. Set it all up, rewrite your integral in terms of u, integrate in terms of u, substitute your x's back in, check your answer. Okay? Alright, let's move on to example 4. And maybe we'll quit our video after example 4 and set up the next one. So for example 4, I want to integrate cosine of 5x with respect to x. This is actually kind of an easier question here because if this just said cosine x, I would know how to integrate cosine x, no problem. That would be the sine of x. However, this 5x here, this oogie boogie, is what's giving me a little bit of a problem. What is the derivative of 5x with respect to x? And that would be just 5 dx. So I am off by a constant multiple, and that constant multiple is simply the 5. So we're going to go to the side, and we're going to say let u equal the thing inside the parentheses, once again, 5x. So then my du equals 5 dx, just like I talked about back here. But I don't have a 5 dx. All I have is dx. So I need to get rid of the 5. This will be 1/5 du is equal to plain old dx. So I have my u here, and I have my dx in terms of 1/5 du, which means everything now will be written in terms of u. I'm not going to get rid of my cosine. That's still going to be part of the problem. This is cosine u times 1/5 du. So the 1/5 can come to the outside. This is the integral of just cosine u, but now with respect to u, which makes this nice and easy to integrate. Since the derivative of sine of u is cosine of u, then the integral of cosine of u is simply sine of u. The 1/5 comes along for the ride, and we do a plus c on the end for a constant of integration. Make sure to substitute our u back in. Don't leave anything in terms of u for our final answer. And that 5x comes back, and we are done. We're going to come over here, and we're going to check our answer to make sure that if we take the derivative with respect to x of this whole entire thing, 1/5 sine of 5x plus c, that I end up getting cosine 5x back. So let's see if we do. I'm going to copy the 1/5. What is the derivative of the sine of 5x? That's going to be cosine 5x times the derivative of what's inside here, which is times 5, and then plus nothing because the derivative of any constant is 0. 1/5 of 5 cancel off, and we end up with cosine of 5x, and sure enough, that was indeed the integrand in my original problem, so I'm pretty sure my answer is correct. And there's question 4. Alright, I think I will quit that right now. We'll come right back to 5 and 6. Talent out.